Hey folks, how we doing today? We've got independent term. We want to find it in the expansion. An independent term of x is just a constant. It means it doesn't have an x multiplied times an x. So what we're looking for is not all the terms in this expansion. We're just looking for the constant. Now, it's not going to be the first guy, and it's not going to be the last guy. It's going to be somewhere in the middle. The first step we're going to have to do is let's rewrite this so it works to our advantage. And that x that's in the denominator, I'd like to get it up in the numerator. Now I'm okay with the 2 being down there, so I'm really just going to pull the 3 halves out front and then raise it to -1. And then I'm looking at 3 halves and I'm thinking, I'd rather use 1.5 x to the -1. All right, so now basically it just becomes an issue of finding out which of the terms. And you know how we go about getting the terms. What we're going to do is we're going to set up our combination first 6, 0, and then we're going to take the first term, x, and it's going to be to the 6th power, because that's 6 minus 0. And then the -1.5, that's going to be to the 0 power. And so you can tell right now by looking at this, when I multiply this together, it's going to be 0.6 x. It's not going to give me what I want. So I look at the next term, and that's going to give me a x to the 5th and an x to the -1. So then I do the third term, and you'll notice how I've got x to the 3rd and then the x to the 3rd. So now all I got to do is do just this one term. And when I figure out, I find the x's end up being x to the 0, which is cool. That's what I want, a 1. And then the coefficient's going to be -67.5. All right. So let's take a look at the next one. Over here, these, we're writing them in vertex form, essentially. And what we've got to do is, well, there's 2 different methods I'd suggest. First, this traditional complete the square method. And basically what we're doing when we're completing the square is we're taking the b term and then we're going to divide it by 2 and square it and add it to both sides. By doing this, we're creating a perfect square trinomial. So like I said, the basic strategy is to create a perfect square trinomial and then factor it. And we'll get the constant out of the way, then we'll take the b term and divide it by 2 and square it, and then we'll add that to both sides. I mean, in a nutshell, that's basically what's going on. Now, the second way to do this kind of problem is to find the vertex. And I can use -b over 2a to do the x part. That'll give me the x part of the vertex. And then if I just take that value and substitute back into the original, well, then I'll know the vertex. And a is always going to be the number in front of the square term. And so what I've got to do is just substitute those values into vertex form. And the a will go there, and then it's going to be the opposite of whatever my x term is going to go inside the parentheses. And then my y for my vertex is going to go at the end. So it doesn't make a difference to me which way you do it, but there are definitely some problems where it's easier to do the second method. So anyway, we'll do the first method for the a, b, and c. And we get the constant away, and then we've got x squared minus 10x. And so now what we're doing is we're going to take the 10 and divide it by 2, and then square it. So then we'll add the 25 to both sides. And see, now once we've got that, I've got a perfect square trinomial. So -20 plus 25 is 5, and now I can rewrite this as x minus 5 squared. Well, now all I got to do is subtract the 5, and I've got x minus 5 squared minus 5. And then remember, when they're asking for a, b, and c, they're asking for the actual numbers, not for the vertex. So in this case, a is 1, and b is -5, and then c is going to be also -5. All right? For b, the first step is going to be to rewrite it so it's in descending order. And then you'll notice that we've got a negative sign in front of the x squared, and we have to factor that out. And that's where people have tendency to make some mistakes in these kind of problems. So anyway, when I factor out the -1, I'm going to get a -1 times x squared plus 8x. Well, the thing is, now I've added 16, but I really haven't added 16. I've added a -16. So on the other side, I've got to subtract 16, not add it. Anyway, the problem will finish out like this. Here in C, same deal. I only can do this complete the square if the x squared has got a 1 in front of it. So I factor it out. Now that's a 36, not a 9. I've just added the one side. And so now when I get this, I end up with a is equal to 4, b equals 3, and c equal -45. Now for these, I'm going to try method number 2, first finding the vertex and then substituting it into vertex form. And so first, negative b over 2a is going to be 1 over 2. And so I know that the x part of the vertex for number d is going to be 1/2. And so now all I got to do is substitute it in the 1/2 wherever it says x squared, and I'll find the y version, the y part of the vertex. And if you're going to enter this, I mean, I wouldn't write this all out, but if you're going to enter this in your calculator, make sure that you put parentheses around all the variables. But when you do this, you'll find out that the y value is going to be 1.75. Well, see, now I've got the vertex, and I already know the a because that's in front of x squared. So I'm going to write it in this form. And so I write y equals a is 1, and so then parentheses, and it's going to be x. Now the opposite of 0.5 is going to be -0.5, and then I put plus the last one, my y value, 1.75. See, now my a is 1, and my b is -0.5, and my c is 1.75. Okay, so looking at E, we're going to do the same thing. First, try to find the vertex. And once I do that, I find out that x is 0.25 and y is going to be 3.25. And so now all I've got to do, I know my a is -4, and so I substitute that in. I take the opposite of the x part of my vertex, and then I put the y part at the end. A is -4, b is -0.25, and c is 3.25. All right, so try F. -b over 2a. I'm going to have a vertex of 1.25. When I substitute that back in, it's going to be a -1.125. I already know the a, it's in front. I substitute it into the formula. A is 2, b is -1.25, and c is -1.125. All right, so let's take a look at number 3. In number 3, they're asking us to find the inverse. And basically when we're finding the inverse, we're going to switch the x's and the y's. And then we're going to get y alone. And traditionally, they're going to love to use quadratics in this kind of problem. And here's an easy version. If we just switch these, x equals 3y squared plus 12, and then subtract 12 on both sides, and then divide by 3, I'm going to end up with x minus 12 over 3 is equal to y squared. And now I square root both sides and get plus or minus x minus 12 over 3, and it's going to equal y. Now here's the deal. You'll notice they gave us a domain. It's less than 0. So that means we didn't use the whole function, and there's a reason for that. Because this is a parabola, and if we do a quick sketch here, you'll know that the vertex, if you take a look at it quickly, the vertex is going to be 0, 12. And so if that's my vertex, well, if I take the inverse of this, it's going to lay down on its side, and then my inverse won't be a function. And so what's happening is by only using x is less than 0, I'm actually only finding the inverse of this side of the quadratic. And then my inverse will end up being a function. So the thing is, my answer here isn't going to be a parabola laying on its side. It's just going to be one half of it. And so what we've got to do is figure out which half is it, the plus side or the minus side. So one way to do that is to take a point that's in the original, and here pick any number that's greater than 0, or I'm sorry, less than 0. So let's try -1. If I put a -1 in there, 15 comes out. Well, that means for my inverse, if I put a 15, a -1 comes out. Well, 15 minus 12 is 3. 3 divided by 3 is 1. So the only way I can end up with a -1 if there's a negative sign in front. So that's how I know what my sign's got to be. It's negative, not positive. Now, as far as the domain goes, all I've got to remember is the domain of the inverse is going to be the range of the original. So if I go back up and look at my original, it was the domain was going to be y is greater than 12. All right. So if that's my range, the domain of my inverse is going to be x is greater than 12, which makes sense because if I put a number in there that's bigger than 12, it'll end up being a negative under the radical, and that's against the rules. All right, so for this one, this is in vertex form already. So let's switch the values. We got x equals y plus 3 squared, and we can take a look at our domain. We're only dealing with the values of x being greater than -3. Well, if you take a look at the parabola, if we do a quick sketch, the vertex is at -3, 0. So again, like the other one, we're only going to do half of it. We're going to do the right side. And so we're going to find the inverse of this side of the parabola, which means that our inverse will be a function. And that's got to be. So now what we're going to do is go ahead and get our y by itself. Well, all we've got to do is square root both sides. And that's going to be plus or minus square root of x. And that's going to equal y plus 3. And then we got to get rid of the 3. And so now the question is, again, whether it's plus or it's minus. So if I pick a point in the original, which in this case 0 is bigger than -3, and that's going to, if I put a 0 in, a 9 would come out. So that means in the inverse, if I put a 9 in, a 0 must come out. So if I take the square root of 9, it's going to be 3. And so -3 plus 3 equals 0. And that's how I know what sign it's got to be. And so now I write my function, make sure you use the inverse notation. And that's that. Now, to find out what my domain is, I look at the range for the original, and that's going to be y is greater than 0. Now, I screw this up and write y is greater than -3, and you got to be careful with that because the range is the limits on the y values, so not the x's, and I screw this up and write -3. It really should be y is greater than 0, and then of course the domain should be x is greater than 0. All right, moving on to C. First, you notice how we got a quadratic again, and if we switch the letters, we're going to get 4y squared plus 8y plus 3. And then you'll notice the domain is x is greater than -2. That's a screw up also. We're going to change that. Make that x is greater than +2. So again, to be clear, this is not part of solving the problem. This question should say x is greater than +2. Not, it's a typo. It shouldn't say x is greater than -2. All right, so let's continue on with the problem. Our domain is all the numbers that are bigger than +2. So now let's go back over here, and I suggest that you do a quick sketch of the parabola. And so in order to do that, it'd be a good idea if we knew what the vertex was. And so if I do -b over 2a, I'm going to get -8 over 8. And -8 over 8 is going to be a -1. And so now I know the vertex is going to be, x value is going to be a -1. And so all I got to do is take the -1 and substitute that into the original equation and find out what my y value is. and my y value is also going to be negative 1. So that gives me this vertex here of negative 1, negative 1, and you'll see that I only want to do part of it. And if I would have done it like the original problem, where x was greater than negative 2, well, you'll notice that I would have both sides of the vertex in my problem. And if I take the inverse of that, then it would not be a function. So what I'm talking about is taking the domain as x is greater than 2. So what I'm doing is I'm only taking this part of the function where x is greater than 2. But you notice I'm on the one side of the vertex. So when I take the inverse, it is still going to be a function. The difference between this and the other first two problems is that the cutoff point was the actual vertex. Anyway, I continue like normal. I go ahead, and you'll notice in the previous problem it was a whole lot easier when it was written in vertex form. And so I'm going to go ahead and put this in vertex form. I already know the vertex, and so it's going to be y, the opposite of negative 1 is positive 1, so it's going to be y plus 1, and then parentheses squared, and then negative 1 at the end. And see, now all I've got to do is get the y by itself. And so basically all I'm going to do is add 1 to both sides. I'm going to get x plus 1 and then divide by 4. And then I'm going to have y plus 1 squared. And so to undo that, I'm going to square root both sides. And I end up with plus or minus square root of x plus 1 over 4. And then when I subtract the 1, this is what I get. Now, again, I run into the problem of which one is it, plus or minus. If you notice the pattern of the problems we've had so far, when the parabola opens up, if it's less than, we seem to be doing negative, and if it's greater than, we seem to be doing positive. But anyway, when I pick original point, if I put a 3 in, I'll get a 63 out. So that means if I put a 63 in the inverse, I should get a 3 out. Well, 63 plus 1 is 64, and 64 divided by 4 is going to be 16. And when I take the square root of 16, I get 4. So the question is, does negative 1 plus 4 equal 3, or does negative 1 minus 4 equal 3? Well, negative 1 plus 4 equals 3. And so that's how I know it's a positive. And I write this again using the inverse notation. And so now to find the domain, I indicate the range for my original. My range is, well, now I've got to take and plug in my x value, which is 2, into the original, and a 35 comes out. So that means when x equals 2, y equals 35. So that means my range is everything bigger than 35 since it opens up. So the domain of my inverse is going to be x is greater than 35. Okay, so let's take a look at D. D is really similar. Why don't you pause this and try doing it. Okay, so hopefully you did try it, and if you did, you started off like this, and you changed the x's and y's, and then my suggestion is that if that you write it in vertex form, and so that way you can kind of get a sense. And so the first step is going to be, I would suggest, is find the vertex. And so doing negative b over 2a, you're going to find out that the vertex is going to be negative 1.5, negative 3 halves, or negative 1.5. And then when you substitute in the negative 1.5, you're going to get out a 1.75. So again, here's my parabola. It opens up because it's positive. I know I've got this vertex at negative 1.5 and then at 1.75. So that gives me pretty much the information I need to go ahead and write this in vertex form. So I go ahead and do that. And that's going to look like this. X is equal to, and then it's going to be y, the opposite of negative 1.5. So I fill it all in, and then I get the y by itself, doing pretty much the same thing I did a minute ago. And I end up with this plus or minus, and then it's going to be y plus 1.5, so then I'm going to subtract the 1.5 on both sides. And so again, I run to this question of whether or not it's plus or it's minus. And again, the pattern is true. If it opens up and we're looking at the less than side, well, then it's going to be negative. But go ahead and try this. Plug in a point that we know is in the original. A number that's less than 1.5 is negative, or negative 1.5 is negative 2. If I put a negative 2 in there, a 2 comes out. So that means if I put a 2 in the inverse, then a negative 2 should come out. Well, 2 minus 1.75 is going to be well, when I do the square root, it'll be 0.5. So the question is negative 1.5 plus 0.5 equal negative 2? Or does negative 1.5 minus 0.5 equal negative 2? Well, obviously it's going to be negative, and so now I know what my sign is going to be, and that gives me this in the inverse notation. Now to find the range of my original, I look up there, and it's going to be all the y's have to be greater than 1.75. So that means that my domain for my inverse is my x's have to be all greater than 1.75. Okay, so let's take a look at the next group. Here we're finding the equation's number of roots. Well, keep in mind the discriminant basically is going to tell us the number of roots. The discriminant for a quadratic equation is b squared minus 4ac. And basically the rules are if the discriminant is greater than 0, then we know that we're going to have 2 roots. And if the discriminant is equal to 0, we know we're going to have 1 root. And if the discriminant is negative, there's going to be no roots at all. And think about the quadratic formula when you're doing this. This is the square root part. So anyway, all I got to do is put in the b squared minus 4ac. And since I'm looking for the k is equal to 2 roots, well, that means that I'm going to have to make this greater than 0. And so all I got to do now is substitute my values and check it out. I end up with 9 minus 4k is greater than 0. And so then I get negative 4k is greater than negative 9. And I divide both sides, remembering to switch the inequality sign. And k is going to be 9/4. So in the scheme of things, I want you to understand that that means that if I had x squared plus 3x plus 9/4, now in this case it's equal, if it were equal to the 9/4, then this quadratic would touch the x-axis at one point. It'd be a double root. Okay? So if I were to take anything less than that, for example in this case, if it was 8/4, which is a little bit smaller, the whole parabola is going to shift down, which now I'm going to have 2 x's. If I had a number smaller than 9/4, it's going to create 2 roots. If I had a number bigger than 9/4, the whole parabola would go up, and I would have no roots at all. So anyway, when you go through the rest of these problems, they basically work the same way. In this case, because I'm looking for 0 roots, I'm looking for it to be less than 0. And then I end up with this. K is going to be greater than 9/20. So why don't you go ahead and pause it and try doing C. Alright, so hopefully you did that, and if you did b squared, in this case, if I'm looking for 1 root, I want it to be equal to 0. So now I got 16 minus 12k equals 0. All I do is get the k alone. K is going to equal to 16/12 or 3/2. K is going to be 1.5. Alright, that's the how you do the front part. There'll be a separate video for the back part of review number 2. Alright, thanks for watching.